Rewinding.
So an eclipse is more about a lot more than just the sound, the sight of the eclipse. It's the sounds, it's the people around you. It's sharing this incredible experience. 10 years ago, my wife and I found ourselves in the deserts of Libya. I can't believe we went there now with the political situation. They're very sad, but we had a rare window of opportunity to go to Libya to see an eclipse from the desert. Spent a wonderful week there, and this is the tent camp that had been erected in the desert with several thousand people to watch the eclipse. Some of my equipment that I had set up to photograph the eclipse on Eclipse Day. And the partial phases again. Now I want to show you a set of three images that shows you how quickly the brightness of the sky changes as totality begins. This is about 15 seconds before the total eclipse begins. We're deep into the partial phases. And I'm getting ready to photograph totality, and I'm pulling filters off my camera. So this is 15 seconds before. This is about 5 seconds before totality. You can still see strong shadows, and then 5 seconds later, totality. So it's very dramatic. And during that same sequence, this is what I'm photographing through the telescope. The last bits of the diamond ring effect, Bailey's beads. There's a bright red prominence, which is a cloud of hydrogen gas suspended above the Earth, the moon, the sun's surface. And then totality. Everybody looking up into the sky, taking pictures, taking it all in. Now, this is a typical single exposure of the corona, and you don't see a large amount of detail. The outer parts of the corona aren't visible. The inner parts are harshly overexposed. This is where taking a whole sequence of images comes into play to produce something that more closely resembles what you see with the eye. So this is after taking dozens of photographs and making what photographers call high dynamic range imaging, to try to get information for both the brightest parts of the image and the faintest parts, and put them all onto a scale where you can see details in the outer corona as well as the inner corona. And all too quickly, the eclipse ends with the diamond ring once again. Of course, I'm photographing every single aspect of the eclipse. Some people think I might get carried away a little bit. So I'm often asked how many eclipses I've been to. This is sort of my world map of eclipses. Every icon represents a location where I've been to for an eclipse. Not all of them have been total. Most of them here are, though. But you can see I've been to every continent for a total solar eclipse. I've been to 27 total eclipses so far. And that boils down to about a little over an hour of time spent in the moon's shadow over a whole lifetime. So this sort of graphically shows this is the duration of each eclipse. I should say the duration of totality, those few brief minutes when you're in the moon's shadow, the duration changes from eclipse to eclipse because it depends on how close the moon is to the Earth at any particular time, the angle that it's moving across the sky, and the projection of that shadow on the Earth's surface, how much of the Earth is rotating with the shadow or not. So the duration can change quite a bit, anything from a fraction of a second up to a theoretical maximum of 7.5 minutes from the surface of the Earth. So you might ask, well, what about this one? Why is that 9 minutes and 23 seconds? That's longer than you can possibly see on the surface of the Earth. Well, we cheated. We chased the shadow in an aircraft out of Tahiti back in 2010. And that's the longest eclipse I'm sure I will ever see, almost 9.5 minutes. But even at that, it's not as good an experience as seeing it on the ground. Even though we were above the clouds and got views through the plane for a long period of time, I would much rather see a 2 or 3 minute eclipse on the ground than a 9 minute eclipse in the Well, that brings us to next year. The United States had its last total eclipse in 1979. It only crossed the Pacific Northwest in the dead of winter and up into Canada. So it was not the best time to try to see a total eclipse, but we've now had a gap of 38 years in which no total eclipse has been visible from the lower 48 states. That all changes next summer with the Great American Eclipse of 2017. The path, as you can see, begins out in the Pacific Ocean, across the U.S., and ends in the Atlantic Ocean. No other nation is in this path. That's why we call it the Great American Eclipse. It's ours. This is a quick little animation that shows you, this is the penumbral shadow. So you can see different locations see the eclipse at different times. As the shadows, there's the umbral shadow, you can see it's much smaller as it moves across the country. So the western part of the country will see the eclipse first, and then the eastern part before it sweeps into the Atlantic Ocean and off the edge of the Earth back into space. Now, quite a large geographic area will see the partial eclipse. This funny saddle-shaped region shows the area where the partial eclipse will be visible. Even parts of Europe will see a bit of the partial eclipse, half of South America, all of North America. But we don't really care about that. We care about the path of totality. I might have mentioned that little 68 to 70 mile wide path. The length of the entire path is about 8,600 miles. It takes the umbral shadow a little over 3 hours from its course in the Pacific to the Atlantic. The section across the U.S. is only about 2,500 miles, and it crosses the entire country in an hour and a half. All of the U.S. will see a partial eclipse. This gives you the fraction of the sun covered at maximum eclipse for various parts of the country. If you're way up in Maine, you still get 6/10 of the sun covered. And down in Texas, what is that? I can't read it. 7/10. But it's only the narrow path where it's 100%. And the reason why, again, that's important is that's where the corona is. That's where you get to see the corona, rather. Visible only during totality. I want to walk you across that eclipse path from coast to coast very quickly, just to give you an idea of the locations that will be in the path of totality for this eclipse. It covers a dozen states and barely nicks 2 others. But it starts off hitting the Oregon coast into Idaho and Wyoming. The Rocky Mountain states, in terms of the meteorology, eclipse astronomers get very interested in weather prospects, because you want to pick a location that has a high probability of good weather on eclipse day. The flip side of that coin is when you're studying climate like this, it gives you the probability of good weather on any particular location. And the problem with that is on eclipse day you don't get climate, you get weather. And the bottom line on the eclipse weather is it's clear every place along the eclipse path on some days and cloudy and others. You can only sort of hedge your bets by looking for a place with high probabilities. These numbers here that'll be on a number of these plots give the probability of, it's the amount of cloud in the sky based on satellite data. So in terms of weather probabilities, you want small numbers. Small numbers means a low amount of clouds. And this location in Oregon, I show this because this is near a little town called Madras. Madras has the best long-term weather probability for the entire path across the U.S. Down around 20 to 25% probability of clouds. Every place else has less of a probability of good sky. Does that mean Madras is the place to go? Not necessarily. This is what downtown Madras looks like, and they're already being inundated by, all their hotels are already sold out. They're well aware of the eclipse. They're going to have a swarm of people there, and hopefully the weather prospects will bear out the weather statistics, and they'll have great weather for the eclipse. In Wyoming, the path goes through Grand Teton National Park. Spectacular scenery. I can't imagine a more beautiful location